Over the last 6 months, I've been spending a lot of time with my 17-year-old college-bound daughter, navigating the world of college planning, campus tours, college fairs, workshops, etc. A few weeks back, my daughter and I spent an entire Saturday afternoon filling out federal student aid forms, the infamous FAFSA, Federal Student Aid Estimator, the Loan Simulator. As we click through page after page of drop-downs and radio buttons and nested forms, my daughter looks up and says, "All these forms are super annoying, Dad. Why can't I just describe my situation in a few sentences and get the number I need, and use my phone to do it like I do everything else?" That question got me thinking about something I wrote, about the future of agent interfaces being conversational and voice first. Here was a real user, my very own 17-year-old daughter, who's grown up with ChatGPT and Claude, frustrated by traditional forms. Layla, challenge accepted. This led me to build a system that demonstrates something broader, a pattern for automating any complex government form through natural conversation, combined with the infrastructure to deploy it remotely. Let me show you how it works. Here's the complete technical stack, a two-phase multi-agent system. Let's drill into the first phase. It starts with the discovery request. Give the agent a government form URL to map. The Federal Scout agent running on Claude Desktop receives this request and starts the mapping process. The agent calls the Federal Scout MCP server deployed locally. This is where the magic happens. The MCP provides browser automation tools using Playwright. Those tools navigate to the actual government website and map the complete form structure. The discovery process produces two critical artifacts. Number one, the wizard structure, a complete automation blueprint telling Playwright exactly how to navigate and fill the form. Number two, the input schema. This is the contract defining what data we need from users. Now the second phase, execution. The second agent of our multi-agent system, the Federal Runner agent, runs on Claude.ai and Claude Mobile, enabling both web and voice queries. The agent calls the Federal Runner MCP server, but this one's deployed remotely on Google Cloud Run. This remote deployment is what enables access from anywhere: phone, web, mobile app. The MCP validates the user's data against our discovered schema and uses Playwright to execute the form atomically. It navigates to the same government website and fills the form using our discovered wizard structure. All of this is secured through Auth0, OAuth 2.1 authentication with dynamic client registration. That's the architecture. Now let's see phase one in action, the discovery process. This is the Federal Scout Discovery Agent, already created in Claude Desktop. Let me quickly introduce what powers it. The agent's core mission: transform government form wizards into machine-readable structures. The Federal Scout MCP server provides specialized tools: starting discovery, analyzing pages with vision, navigating wizards, capturing screenshots and their structures. Let me ask the agent what it can do. The agent explains that it generates two critical artifacts for each government form: the wizard structure for Playwright execution, and the user data schema, the contract defining required inputs. The agent is inviting us to get started by providing a URL. Perfect. Let's give it one. I provide the Federal Student Aid Estimator URL and the context: my daughter's a high school senior looking at colleges. Watch what happens on the right. The agent immediately connects to the browser. There's the Federal Student Aid Estimator landing page. The agent analyzes it with vision and identifies this as a multi-page wizard. Perfect. It's initiating the Estimate wizard. And we're in. Page 1, Student Information. This is where the discovery magic begins. Watch the systematic approach. The agent reviews the page screenshot and analyzes the page element data. For each field, it extracts the selector information, data type, and validation rules. Then it generates the test data and calls execute actions to fill this data in the form via Playwright. This is Playwright being the hands. With all the fields filled, it saves the complete page metadata and advances to page 2. This is the pattern. Analyze, extract, fill, save, and advance. Now watch this happen across all 7 pages of the wizard. Page 2, student personal circumstances. Page 3, parent marital status. Page 4, parent information. Page 5, family size. Page 6, parent income and assets. Page 7, student income and assets. And here's the results page. Discovery complete. 7 pages mapped, 47 fields documented. 2 files created. Let me show you what's in each. First, the user data schema. This is the contract. Look at the structure. Every field the wizard needs defined with its exact data type, whether it's required, validation patterns. When the federal runner executes later, it knows exactly what to collect from the user. Number 2, the wizard structure, the complete automation blueprint. See the page-by-page mapping, field selectors, interaction types, navigation buttons? This tells Playwright exactly how to fill and navigate the form. These 2 artifacts work together. The schema defines the data we need. The structure defines how to automate it. Contract first pattern in action. Let's discover one more federal form, the loan simulator. These 2 forms together create a realistic example for execution. First, estimate your financial aid, then simulate borrowing to cover the gap. This time, notice I don't even provide a URL. The agent searches and finds the Federal Student Loan Simulator page. Check this out. There are 3 different simulators on this page. Based on the context of my query, simulate borrowing for school, it picks the right one, the Borrow More Money Simulator. That's smart reasoning about context. Same discovery pattern, but let's move through it a bit faster. Page 2, program details. Page 3, family income. Page 4, loan amount. Page 5, salary projections, post-graduation. And page 6, loan simulation. This page is complex loan entry section, where multiple loans can be added. The agent is smart enough to identify this as a repeatable field group structure. And finally, the results page. Discovery complete, 6 pages mapped. 2 more artifacts generated. Both the wizard structure and the user data schema ready for the federal runner. In about 5 minutes, we've mapped 2 complex multi-page federal forms, 13 pages, nearly 70 fields. No custom integration code required, just vision-guided discovery with a universal pattern. These artifacts are the foundation, the contracts and the blueprints that power Phase 2. Now let's see them in action. Phase 2 starts here. Claude.ai projects. So why create the agent on Claude.ai instead of Claude Desktop? Well, my daughter needs to access this from her phone. That means the execution agent needs remote MCP infrastructure, not local tools like Discovery. With the runner agent created, let's configure detailed instructions. The federal runner transforms government forms into voice-accessible conversations. And it's part of a 2-agent, multi-agent system. The federal scout discovers, the federal runner executes. Now, the critical step, connecting to the remote MCP server. Let's add a connector for the custom federal runner MCP that we deployed on Google Cloud Run. Now, here I need the MCP server URL. Let me grab it from Google Cloud Run where it's deployed. Switching to Google Cloud Console, let's go to the Cloud Run service where the MCP endpoint is deployed. There it is, the federal runner MCP endpoint deployed and running. This is the metrics page for this MCP endpoint, and that provides 3 specialized tools for federal form automation. And there at the top is the MCP endpoint URL. Let's copy it. That's what we need to add the connector in Claude. Now, let's paste the endpoint URL and click Add. Now that we've added the connector, we need to authenticate it. There's the Auth0 login page. Since our MCP endpoint on Google Cloud Run is publicly accessible, we need authentication. That's handled by Auth0, an OAuth 2.1 service that I'm using that authenticates users and issues access tokens for secure MCP tool access. Let me show you how the OAuth 2.1 server is configured. Here's the Auth0 API configuration. Notice the API identifier matches our Cloud Run URL. And we've configured 2 scopes, Federal Runner Read for listing wizards and getting schemas, and Federal Runner Execute for running forms. And here's the magic that makes all of this possible. Dynamic client registration enabled. This is what allows Claude.ai and Claude Mobile to register themselves as OAuth clients automatically. No pre-configured credentials needed. Now, let's grab the user that's authorized to authenticate against this endpoint. Let's copy the username, and we'll use it to authenticate back in Claude.ai at the Auth0 login page. The Auth0 consent page. Here, Claude is requesting access to the MCP service. Let's accept it. Authentication complete. But how do we know Claude successfully connected to the MCP endpoint? Let's click Configure. We see Claude able to successfully retrieve the list of tools the MCP server exposes, indicating successful authentication. The OAuth 2.1 MCP handshake is complete. Let me break down what just happened. Step 1. Claude discovers the OAuth endpoint from the MCP server's well-known URL. Step 2. Using dynamic client registration, Claude registers as a client with Auth0. Auth0 responds with the login page we just saw. Step 3. User login and consent page. We authenticated and granted access. Auth0 issues an access token. Step 4. Claude uses that token to retrieve the tool list from the MCP server. This pattern works identically on Claude.ai and Claude Mobile. One auth flow, everywhere access. The runner agent is ready. Let me ask what it can do. The federal runner introduces itself, intelligent form execution contract first automation. And it states there are 4 federal forms currently available, including both we just discovered. The agent is inviting us to get started. Perfect. Let's switch to mobile. Okay, so I've just switched over to my Samsung Galaxy Z Fold 7. Let's go ahead and launch the Claude app. And let's find the runner agent we just created on Claude.ai and create a new chat. Now here, I'll play the persona of my very own 17-year-old daughter, high school senior, exploring colleges. I'll click on the mic icon with my first query. Hey, runner agent, can you help me figure out if I can afford Northwestern? I just toured it and it costs like $85K a year. We're from Illinois, and I'll be a freshman in the fall of 2026. The agent retrieves the list of available wizards, and it identifies the FSA Student Aid Estimator as the right calculator and loads the schema, the contract defining what data it needs. Okay, so the agent has a bunch of questions organized by category. Let's answer them, continuing to use the microphone. I was born May 15, 2007. My parents are married. We're a family of 5. Their income was about $200K last year, and we have about $100K in savings. No dependents, no child support. Okay, so the agent has 2 further clarification questions. Let's answer it. Nope, didn't work last year, and none of those special circumstances apply to me. The agent asked for confirmation before execution. Let's confirm. Looks good to me. Check it out. The MCP validates this data against our discovered schema. Then Playwright automates the 7-page form. All 7 pages being filled automatically. Playwright navigating, clicking, entering data based on the wizard structure from phase 1 discovery. Ah, perfect. The agent completed. My student aid estimate, about 7,481 per year. My SAI index, that's used to determine how much aid that my daughter will get, about 43,000. And the gap between aid and what I need for Northwestern, about 75K per year. Okay, so the agent asks if I want to run the loan simulator to figure out how to make up for the gap. Okay, let's follow up with another query on the loans I would need to cover this gap. Yes, let's run the simulator. My parents said they'll cover about 75%. What loan should I take for the rest? I'm thinking business major, probably making like 65K a year after I graduate. Okay, so the agent loads this second schema, the federal loan simulator, and now it's automating a different government calculator, the 6-page loan simulator using the same contract first pattern. Cool. It came up with the 3-loan strategy. Number 1, a direct subsidized loan at $3,500 at 5.5 interest rate. The second one, a direct unsubsidized at $2,000 at 6.53. And the rest covered by a Parent Plus loan, about $14K at about 9% interest rate. I like this. It also provides a reality check of the monthly loan payments after graduation for both my daughter and us parents. Okay, the agent answers the original question. Yes, Northwestern is affordable with this strategy. 2 minutes, 2 federal calculators, official government results. No forms, no clicking through pages, no confusion. Just natural conversation with voice on a phone. My daughter asked, can I afford Northwestern? And I got an official federal aid estimate, exact funding gap calculation, and an optimal loan strategy with payment projections. This is what government services should feel like in 2025.